Critical Siege Theory number 4. Okay, this is my second time recording this because I realized I had an error in the calculations I was making. So what are we talking about today? We are talking about round counts. In the first iteration of this series, in Critical Smash Theory 1, I was talking about what makes a team good, and what makes a team good basically is the ability to win rounds. So I was talking about the win conditions for winning rounds and all this stuff. I think that was in the first one anyways. So we're zooming out a little bit from that, and instead of talking about how to win rounds, we were talking about how to win games, i.e. the combinations, not necessarily how to win games, but how games are won and how games are finished. The combinations of rounds won by either team to end the game. So we are talking about competitive play, which is first to 7 unless both teams reach 6, unless they go 6-6. In which case, it is then first to 8, i.e. a best 2 out of 3 at that point. In some matches, you play unlimited overtime, and so you have to win by 2 points in overtime. You have to get, once you get to 6-6, you have to win 8-6, 9-7, 10-8, like that. But we're just going to be considering the case, the normal case, where you win by 2 rounds, or rather, where it's a best 2 out of 3. Once you get to 6-6, so first to 8 after it goes 6-6. Okay, so winners rounds here, loser rounds here, total rounds, combinations, formula, simplified. Okay, what is all this? I mean, a lot of it's pretty clear. This is the number of rounds won by the winning team at the end of the game, and this is the number of rounds won by the losing team. This is the total round played, so it's just this plus this. This is combinations. This is how many ways that can go down. That's the formula to find it, and this is just a simplified version of these formulas here. Okay, so technically you can double all of these values if you are just looking, if you're going into a game and you're not assuming anything at all. Like right here, I'm taking whichever team won, so the total number is being divided by 2. But this is much easier for our case. So like if, it's SSG versus TSM and you're assuming either team can win, then you just double all of these values because in this case of a 7-0, TSM can 7-0 SSG or SSG can 7-0 TSM. So there are 2 combinations and you just double that for all of them. Anyways, we're considering this case though. All right, so 7-0. So how do you find it? This is just the choose formula. It is just 7 choose 1. Or rather 7 choose 0, because the losers aren't winning any rounds, so it's literally, there's only one way to do it. It is just whoever ends up winning the game wins all 7 rounds of the game. They win 7 rounds in a row. Okay, it's simple. And then it gets a little bit more complicated from here. The winner has to win 7 rounds in all these cases except for the overtime conditions. So now the loser is winning 1 round. So the loser can win the first round, the second round, the third round, the fourth round, the fifth round, the 6th round, the 7th round. But there are 8 rounds. The loser cannot win the 8th round because that implies that the first 7 rounds would be won by the winners. But if the winners win the first 7 rounds, the game already ends. So what do you do to rectify this? You have to subtract the previous formula effectively, and this will end after we get to the overtime thing. Because at that point, it then just becomes the case of if the losers are to lose, and it looks simple here, but it gets more complicated as we go. I mean, this is just subtracting 1, but then you have to subtract 8, 36, 120. You're assuming the very last round goes to the losers, and this is for the purpose of eliminating cases, and then you just have to run the previous one. So, just 7 choose 0, because you're chopping off that last round. So now the losers win 0 rounds in this hypothetical scenario, and there are 7 total rounds played, so it is just literally the previous scenario that you're cutting off. But like in this, so it's just 8, it's minus this. But if you've already subtracted from it, you don't take into account the subtraction you already made. So this ends up being 7. For the next case, you do 36 minus 8. You don't include the subtraction you made. Okay. And it's a little bit hard to explain why. I mean, it's just the way it works. Maybe you already understood what I was saying. Okay. So it just goes all the way down, increasing number of combinations: 1, 7, 28, 84, 210, 462. And then we go to overtime. And now that case where in all the previous ones, the loser could not win the last round of the game, but now the loser can win the last round of regulation. So it is just 12 choose 6, which is 924. And then you play overtime, and the overtime doesn't affect anything because if there are going to be 14 rounds, that means the winning team wins round 13 and 14. So you're just multiplying by 1. Okay. So the number actually does get like quite a lot bigger. It's like, what? That's over double? No. Yeah, over double. No, exactly double. Yeah. Right? Why can't I count? 800, 900. Yeah, it's just double. There's now twice as many scenarios. Okay, just the way it works out. And then you actually just double it again in overtime because so you have all the combinations from the max regulation, which was this formula, and now you just have to take into account the best 2 out of 3 that is played. And the winner has to win the 15th round. That's just how it works out. That's why they're the winner, because they win round 15. So then the winner can win round 13, or they can win round 14, and the loser wins the other of those 2 rounds. So there's just 2 combinations, so you're just doubling it. And then you get 1,848. So this is just the sum of all of these. So this is how many different ways a game can go when taking into account the different round counts. Now, of course, there's it's like a much, much, much bigger, if you consider, if the plant went down or not, if it was disabled or not, how many players were left alive up to 10 can technically be alive, and down to 0, are there 10, 9, 8, 7, 6? How many were on each team? If this which objective, there's so many different combinations, but if you're just looking at rounds 1, there are 3,564 different ways it can happen in one standard game. And then of course the number also goes up if you're looking at in a series, a best of 3, a best of 5, whatever it is. And I'm pretty sure I got this calculation right, because originally I had all of it and I forgot to subtract off the numbers. And I was sitting here for a long time, and I was like, why? What did I do wrong? And I was like, oh yeah, I figured this out quickly, but then how to fix it took me a little bit. And then I had to sit and also think how this affected overtime. And it turns out it didn't really affect overtime. I'm pretty sure. I imagine nobody is going to both watch this video and understand how to fix a mistake if there is a mistake, and it's very unlikely. But if you notice I somehow did make a mistake, let me know. I just doubt it's actually going to happen. Because I think I got it right, but maybe not. All right. Because I know this is 1 for sure. I know this is 7, and then I'm pretty confident about the rest. Is there anything else to talk about here? I don't really think so. Just one more time. Simplified. It's simplified. So this, I guess maybe I should have done it earlier, but I'll just explain this. Is 7 choose 0 is a way to say it, but it's 7 factorial. And what factorial is, it is just that number multiplied by the number 1 lower than it, and you just repeat that process all the way down to 1. So this is 7 times 6 times 5 times 4 times 3 times 2 times 1. And keep it 0 factorial is defined as 1. It's the same as 1 factorial, just the way it works out. You can prove it, but mathematically, but just take my word for it for now. So this is just 7 factorial divided by, so this is 0 factorial is 1 times 7 minus 0 is 7 factorial of that, so it is just 1 times 7 factorial. So this ends up being 7 factorial divided by 7 factorial, so it's 1. This first part ends up being 8 factorial divided by 7 factorial. So the 7 factorial cancels with the 7 factorial, leaves just the 8. So it's just 8 divided by 1 basically. And then you set this part over here is 1, as we figured out before. And then so on, so forth, figure it out. So, and one interesting thing I want to note, of course, disregarding the skill of each team and whatever, like a 7-0 of a pro league team against a silver stack, it's like really likely, right? They're just going to demolish it. But say they're like equal, say 2 teams are exactly equal skilled and coming into the day equally everything, whatever. If you're assuming all possibilities are equally likely, a 7-0, 7-1, all the variations of all of everything, there is only a 1 in 3,564 chance of a 7-0. Which is, I mean, it's a really small number. It's like 0.0028% or something. It's like, you know, less than, well, yeah, less than 3 out of 10,000. Really small number. And then, I mean, this is even, a 7-1's even pretty likely because it's just like it's less likely than 1 in 500. So also pretty unlikely. I guess there's not anything else to talk about here. It's just a little breakdown of how this works. There's not really any conjecture going on here, but just maybe a little bit of analysis. Yeah, that's gonna do it. This was Critical Siege Theory 4 round counts.